Only at prescribed moments.
Yeah.
I think we're back.
He was probably.
Those of you who are making your way into the room, please find a seat. It doesn't have to be the same seat you had earlier this morning. And if somebody's in your seat, find another seat.
Yeah.
Is it not working? It's on, but it's not doing anything. I'll use this mic. Okay, we're going to do the breakouts, and we're going to do them in following the order of the presentations, which just disappeared from the screen up there. So the first group is going to be the one that stayed here, which was on innovation. Thank you. About 5 minutes per breakout. And we do then, following the breakouts, we are going to have a plenary on assessment, and then we do lunch. And so I'm looking for whoever has the good fortune of reporting out for the innovation team. You can come up here. You can go to a mic there. But this is probably this one. We're not.
I'll put my notes down at least. So we had a lot of very exciting conversation about partnerships, innovative ways to do them. We all agreed that partnerships are incredibly important going forward. Collaborations are critical between societies, and we have a long way to go to improve communication between our societies as well as the market overall, so that we can work more effectively together. We did ask the group to email in additional ideas, so when the proceedings come out or the notes come out, we'll be sending some more of those along. But some themes that emerged, there were two significant themes. One is that effective collaborations are project-based. Going in with some vague ideas or some themes that you may want to work around usually doesn't get to an effective outcome. Project-based with a tangible result are usually the best ways that we collaborate together as societies. And the other theme was that we all need to do something bigger than ourselves. We all need to rally around some larger initiative in engineering education in order to affect change. Some projects that we did discuss. One, ASCE is creating an IMAX movie. It's a $15 million investment. Very impressive. Possibly looking for partners to help with that. But, just to create awareness, to kind of teach children how to dream, teach teenagers, even adults looking for career changes on how to dream, is something on an advocacy basis that we all probably need to rally around. All of us are doing some level of student competitions, whether they're design competitions, manufacturing competitions, whether they're K-12, community college, university. We're all engaging in those, and maybe there's ways we can collaborate more effectively together around themes that impact our members, whether we're verticals or initiative-based organizations. And we talked a lot about resources. One that came up that was very interesting was the Frameworks Institute, frameworksinstitute.org, and they provide a lot of tools around communication, around research, reports, and other things that can help us effectively communicate the value of STEM education, how we might be better in STEM education, how we can have a better awareness of the audiences we're speaking to. So talking to a K-12 audience, very different than a college, different than the millennials in the workforce. So how do we keep them engaged, and how do we advocate for the education? AAAS, so AAAS has Portal to the Public, which is another resource that we talked about. And one of the ideas that came up that we thought was a very interesting idea was having an ASEE task force on engineering education. And what can we do better, and how do we cascade down improvements in engineering education that then the vertical societies can pick up to then make their guidance and their recommendations for that. So those are our themes. If anyone in Group 1 has anything else they want to add, I think we might have a little bit of time. But those are the general themes that we came out of. And again, we asked our group to submit ideas in via email, so we'll communicate those out as well as part of the follow-up on the meeting. Absolutely. I think you need to step over to a microphone, though.
So you mentioned teaching people how to dream again, whether that's for young students or people changing career fields, maybe being displaced by different industry changes. What does that mean to your group, and when you're making the movie? What does it look like to change like how you dream about things?
Well, I think maybe our chemical engineer folks could address that one from the movie perspective. Where'd you go? Civil. Sorry, civil. I apologize. I had chemical was the last one that spoke, so I had chemical on the brain.
That's okay. I'm Jim O'Brien. I'm with the American Society of Civil Engineers, and a couple points to make on Dream Big. First of all, many of your societies here have already contributed to the film, and we've already raised the $15 million we need to have that film come out. It premieres on the 15th of February. Go out and see it. It's a great thing. It's not for you, by the way. It's for middle schoolers and high schoolers to learn about engineering, and it's all engineering, not just civil engineering. And what Dream Big means is imagine the possibilities. Imagine who you can be. Imagine what you might be able to pursue if you pursue the career, the profession of being an engineer. Thanks very much.
Okay, thank you. On to group 2, which is promoting diversity. I'm assuming you figured out who your spokesperson was. Just okay.
All right. So our group was again discussing diversity and inclusion. We had a couple major themes, and one of them was first acknowledging we have general standards that are across all of our different societies and different engineering fields, even different industries. The challenge is that those are a little bit siloed, and so if you have a toolkit and you have a toolkit, how do we crosstalk? And some of the limitations for that are definitely funding sources, risk versus reward, and then communication in general is always a challenge. We also want to know what are the success criteria and the successful strategies, and we looked at inspiring success stories, but also being able to show really concretely why it's impacting not just the minority group that we're featuring the diversity for, but also for the macro impact, and being able to give very clear terms in addition to the well-marketed, teaching people to dream type stories. But really rounding out that entire perspective to change the attitudes of the full industry. We looked at a gap assessment, so who's in the room right now and who's not. And we identified if we have all the academics in the room and we come up with the solution and we don't have industry partners or different fields, we might miss something. And so this idea of academic and industry group affinities and being able to collaborate horizontally will really improve our chances for success. We identified a few things that have been really successful. So one, NSF and the different grant agencies being able to require broader representation and inclusion as part of the grant success metrics. And so as we look at what are the success metrics, whether it's for in an academic world, getting people to apply and be accepted to a university, and if we weight everything by GPA, perhaps we're missing some things, as well as for a grant, what are the desired outcomes? Is it just technical knowledge? Is it inclusion? Is it diversity? Is it somewhere in between? And how do we well define that? Some of the points that were made were the mandatory nature and the higher emphasis on the success criteria, including diversity and inclusion, actually helped make people who represent that in their departments feel more actually utilized instead of just a metric. And that in type of inclusion made them more likely to want to participate and definitely succeed more impactfully. And then we looked at what's driving success. So we know that my background from aerospace right now, there's about 11 to 13% at most universities of a gender split. And so comparing that to environmental engineering or biomedical engineering, where the numbers are much closer to parity, what is the difference? And an easy low-hanging fruit is certainly that it's societal impact and societal change. But some people in our group really point out that that's not the full picture, that's just kind of the first level. And we also looked at what are the clear impacts and outcomes from the career field or from the industry, and that those are not as well understood at the start of an undergraduate education. And then just because you're able to join the group, if you make it into the success criteria as currently defined, does that give you the actual inclusion of your full person? And so instead of creating a fringe minority that's not well connected with the rest of the group, how do we better define our groups and our systems in order to have that higher crosstalk, and from that being able to have a better collective impact, which will better affect our shareholders and stakeholders. Any other thoughts?
Thank you. Up next, fostering interdisciplinary engineering education.
Good morning, everyone. I'm Bert Dicht. I'm with IEEE, and it's my pleasure to do the report out for our team. Let's see. There you go. Yeah, electrical engineers. Okay, here we go. There. Okay. So this was our team. I apologize. We didn't have time to put everyone down, so we took a picture of the sign-in sheet. But it was a really great team, really great discussion. And what we were talking about, fostering interdisciplinary engineering education. So we wanted to assess the feedback on the lightning round, just see what our impressions were. We actually had a quick discussion on what does interdisciplinary mean, identify potential programs, and discuss the barriers. So in terms of the lightning round, just framing some of the things that came out of our discussion, there was good information, but really, again, the focus really was on the particular societies or programs, and we're talking about being able to collaborate more. We did discuss specifically Engineers Without Borders, the scalability of those programs. How do we engage other groups of engineering students in larger formats? We also had a discussion about how AES works and got a good understanding, and maybe they could be a link for collaboration. How do we collect those interdisciplinary brands that were discussed today? And one key point that was raised, does engineering education move fast enough? It's really falling behind the real world needs, and there are some good examples of how we're maintaining that, like with sustainability, for example. Along with that, teaching engineering we're teaching engineering in an unexciting way, and we need to emphasize. I think someone mentioned it earlier. I think with Jim's point about dream big, the impact engineering can have for the good of society. And we actually need to integrate these societal issues into the curriculum, and also how do we make engineering programs more accessible to students who maybe don't start out as engineering students, maybe they're science or math students and so on. So a quick discussion on what does interdisciplinary mean, and obviously it doesn't mean you have to be an expert in every area, but it's being able to interface and work in an effective team, understand how those other disciplines work and how they play into your team. Some programs already have students working outside of their areas. We got a good example of maybe finance majors being part of a team, but they're actually doing some engineering work, learning how to do that, whereas engineering students are doing things that are non-engineering. So giving people a taste of working in those other disciplines. And right now, too, there are great examples of many programs or fusions of different disciplines, and bioengineering is one of those. And finally, we said capstone projects. They're a good tool for actually encouraging interdisciplinary activities. So what types of programs do we see maybe are needed? Obviously, linking the technical professional societies to the engineering curriculum seems like a really good approach. And we could give students credit for the work they're doing in these professional societies. And it'll make the professional societies happy as well, along with the students. But included in that, if we are going to give them credit, we'd have defined learning objectives, we'd have assessments, and so on. And we want to closely match up society activity, technical professional society activity, with the ABET criteria. Use faculty to help drive that, and actually give faculty credit for teaching, for taking part in this. Let's see, I did that one already. One great idea we had was to create a multidisciplinary challenge among the societies. That means IEEE, ASME, the civils, AIAA. We would work together to create a competition or challenge among all of us that would go out to all students, and it would require multidisciplinary teams to be part of the entry. And it could be something that we could spread out working together. It seemed like we had a lot of support for this idea. One other idea that created a little bit of controversy, obviously we wanted to start with freshmen. We need to get freshmen understanding what interdisciplinary means, but possibly even incorporating some other subjects that are non-engineering directly into engineering courses like mathematics and so on. So that one generated a lot of comments, discussion, more to come on that. But some of the barriers that we saw, culture, no credit for faculty advisor activities, teaching load is critical if we're going to get faculty more involved, and really the reality is engineering education is very siloed at this point, and how do we break down those silos? And that's it. So anything I missed, team?
No, you did a great job.
Okay. Thank you.
When's the movie coming?
Oh, we needed another 15 minutes to put that together.
Okay, thank you. And last up, raising awareness of engineering disciplines.
Hello, my name is Charlie Reinholtz. I'm the department chair in mechanical engineering at Embry-Riddle Aeronautical University, and this was a really fun group for me to be a part of. A lot of like-minded people that are involved in the SAE competitions and the AIAA competitions. So we talked about a number of different issues. I'm sure I will miss some. I hope Amy and others will help fill in some of the gaps. But we really divided our discussion into two areas. One was best practices, and one was other types of activities we could be doing. So looking at best practices, a focus that came up over and over again, we divided into two groups, and I think both groups had a lot of the same thinking, was it all boils down to marketing. We all agree, I think, that we don't market what we do very well. The general public is not very aware of what engineers do and why it's exciting. High school students don't usually find engineering that exciting unless they have some insights that the typical student doesn't have. To contrast that, best practices, look at the NCAA and athletics. I see no reason at all why the collegiate sports that we run in the high school sports can't have an analogy in academics where students from, and some of the examples that were cited were really interesting, like the FIRST Robotics, of course, is one. There is the something I wasn't familiar with called esports. There's another one called STEM Premier, where students are, and I think Gregory and I actually had thought of it myself, the analogy where students are recruited into college, and we've all seen it on TV, the National Signing Day, and they have the hat of one university or the multiple universities, and then they put the hat on. That's what we need in academics. I think we all agree that that's part of what's necessary. So raising public awareness and media awareness, and how do you do that? If you could recruit students from, for example, a FIRST Robotics team to be on the new SAE driverless car competition or one of the AUVSI autonomous vehicle competitions, which is what we're trying to do, you give them a goal, but you also can give them a role. If you take the things we're doing now, giving academic scholarships, and turn those into an NCAA-type scholarships where a student comes to campus with an expectation. They don't just get the money and get good grades. They come and they're part of a team and they're part of a culture. They have the framework on campus for support, their study sessions. They come to meet with the team every day or 3 times a week, and maybe they're even recruited into a particular role on the team. They're coming to college to be the SAE drive team lead. That's exciting. That's something that students can get really excited about. So I guess overall we saw the NCAA and what they're doing as clearly a good practice. The one thing we have that the NCAA doesn't have, we have lots of jobs at the end. They only have a teeny fraction of the people that participate in the NCAA activities ever will work in the area that they have been recruited into school with a scholarship to get. So there's really not much of a prospect of jobs at the end, but for engineers there's limitless prospects. So the NCAA is like a PR and money machine. There were some great comments about trying to close the valley that occurs between society membership. We get students about we get them excited about being members of student organizations when they're on campus, and then they lose that interest and they don't rejoin. Sometimes later, maybe 5 years after school, they rejoin ASME or SAE, but trying to close that. And I know some of the engineering societies are offering reduced membership or free membership the first year you're out of school, so that seemed to be a best practice. Trying to humanize the technology, and I'm not really sure what examples were raised there as best practices. Can anyone help with that?
It's all about humanizing discipline as opposed to focusing on the tangible piece or tangible item that we actually sell. Taking that human aspect along with it.
Mm-hmm.
What happens to the individual and the
Okay. I had that written under best practices. Maybe that's other types of activities. I think we're trying to do that, but how? Can someone cite good examples of
we
where
need
that's
people
being...
to go to the mics, though.
Yeah. Okay. Yeah, I think another point that was raised under other types of activities. Oh, I'm sorry.
Well, to the point about humanizing a lot of the publicity about science and engineering story about let's just say as an example, an inner city student from a disadvantaged school who happens to have a camp experience or some type of project experience that inspires them to go on, go to college, get the right degree, and now at the end of the story they're a mid-level or entry-level engineer at, let's say, Boeing or Lockheed Martin or something like that. Those kinds of stories we feel can inspire younger people, students to enter the profession. And we want to emphasize that type of communication as opposed to the neat fix that we did on this particular component of this particular system, right? So it's about the people, not the stuff.
Great. Thank you. Yeah, and then under other types of activities, there was also, I think, discussion in both the subgroups in our session about the need to get marketing and media people involved. But I think that not only... we know it doesn't work to just invite the TV channel or the local newspaper out. You get some local short-term coverage. It doesn't get the general public excited. We need to be designing competitions and designing the structure of what we do, giving continuity to students going from middle school to high school to college and on to professions. There needs to be continuity there in marketing what we do and making sure that when we have these they're incredibly exciting competitions if you know what's going on, but if the general public comes, most of these competitions, they're too long. They don't fit the format of being on TV or coming out for a few hours to watch. So we need marketing people. A good example to me is the NASCAR just tweaked their rules. Every year they tweak the rules to try to make the competitions a little more exciting. We need people, and those aren't the engineers and the drivers that are tweaking the rules. They're people that are thinking about how do they get the public excited about this and keep their interest so they don't leave the race early because it's not meaningful anymore. We need people like that thinking about how we design our competitions, how we get our students excited about things. What have I missed? I invite other, Gregory, thank you. Okay, thanks.
Okay, thank you.